Good morning, my YouTube viewers. It's Crystal here, and I'm here this morning because I wanted to give you a code review. And basically, what I wanted to do is, I wanted to go over a data set for credit card fraud. And this was a Kaggle community competition, and so I have created the Jupyter Notebook in Kaggle's website, and the Jupyter Notebook is stored in my account. But what I will do, I will leave a link to the Jupyter Notebook in the description box down below, so if you want to look at the Jupyter Notebook, you can. And what we're going to do is we're going to use an imbalanced data set to predict on credit card fraud. So I used it doing TensorFlow, and I got a score of 40, and the highest score was like 50. So the highest score was only 50%, and I scored 40. And I tried several times to improve the score by using different activation functions, using different neurons, using different neurons, like different numbers of neurons, and all kinds of things to improve my score, but that just was the highest that I was able to get at. But we'll go ahead and go through the code review anyway, so you can see what I did. So the first thing we're going to do is we're going to talk about the problem statement. And the problem statement is detect credit card fraud and an unbalanced data set. So after we've gone through our problem statement, what we're going to do is we're going to import the libraries that we're going to need to execute the program. So we're going to import NumPy as NP, and that creates your numeric, your arrays, creates your NumPy arrays and computes numerics. We're going to import Pandas as PD, which creates the data frames and processes the data. We're going to import OS, which goes into the operating system. We're going to import sklearn, which provides machine learning functionality. We're going to import matplotlib.pyplot as PLT, which visualizes the data. We're going to import Seaborn as SNS, which also visualizes the data statistically. And we're going to import plotly.express as PX, and that's another graphic visualization package that, because in order for me to do this class imbalance, I had to look at other code. And when I was looking at other code, I found some graphics using plotly.express as PX. So and we're also going to import TensorFlow, because that's going to create your neural network. So after we have imported the libraries we would need, we're going to use OS to go in and get the files. And there's 3 files. The 3 files are sample submission, train, and test, and these are CSV files, and they're used to execute the program. So after we have retrieved the files, we're going to use Pandas to read the files and convert them into data frames. And the 3 files are train, test, and submission. So you can see train is 18,000 rows by 9 columns, and the last column is fraud. And then you can see train, the ID is int and fraud is int, and everything else is a float. Check for any null values. So there's not any null values, so we don't have anything that we need to impute. And then we have test, which is The same as train, except for the fact that it doesn't have a fraud column because fraud is your target. And test is 2,000 rows by 8 columns. We check for any null values, and we don't have any null values, so we don't have anything to impute. Then we check submission. This is what Kaggle wants to see when you submit your predictions. They want to see the ID and the fraud columns. So now what we're going to do is we're going to analyze the target. And this is the code that I got from Plotly, just to make a diagram where you can see the distance from home and whether it's fraud or not fraud. So that was very interesting. And now what we're going to do is we're going to take the target, we're going to define the variable target, which is the fraud column, and we're going to pop the fraud column out of train, and we're going to use Seaborn to analyze it. And you can see that you have a lot of zeros and not very many ones. And what we do is I created a data frame called fraud. And so not fraud is going to be your 0 and fraud is going to be your 1. So you've got 16,452 not frauds, which is 0. And you've got 15,4A frauds, which is 1. So now we're going to use Seaborn join plot to create another plot from distance from home and the target. So that was very interesting. Now what we're going to do is we're going to drop the ID because you don't need the ID. And the reason why is because in Pandas, every row of data is indexed already. Now what we're going to do is we're going to use SciPy to do the Kolmogorov Smirnov test to see if there are any columns that are not from the same distribution, and you don't have any columns that are not from the same distribution. But that's just a test. So like if you had any columns that are not from the same distribution, then what's going to happen is that it's going to affect your predictions. So I just checked that. It's Kolmogorov Smirnov test, and it's in the SciPy library. So we're going to analyze train. We do a describe, so you can check all of the float columns, and it gives you information on all of the float columns. And then what we wanted to see was we had a total of 18,000, but ones were 1548. And let's just look at this right here. Yeah, ones were 1548. And that's just something that I got off this website to try to deal with class imbalances. But that tells you the percentage of total. So it's 8.6% of total were positives, which means it was fraud. So now what we want to do is we want to see what the unique values in each column are. So we do for call and train, print call, train call, in unique. And so you can see distance from home, distance from last transaction, ratio to median purchase price. You can see that those have a lot of unique values. But repeat retailer, used chip, used PIN number, and online order don't have a lot of unique values. You only have 3, 4, 4, and 2 unique values. And I suppose what I could have done if I had 1 and 2, I could have created a heat map to see how closely correlated the columns were. And if any of the columns were closely correlated, I could have removed them. But since there were only, I think, 7 columns of data, I thought, well, that's not a whole lot to remove, so I thought I would leave it the way it was. But I could have done that. I could have made a heat map and to see which columns are highly correlated, and if there was a highly correlated column, to remove it. And now what we're going to do is we're going to standardize the data. So train equals train minus train.mean over NP STD train. And we did the same thing for test, because in this particular competition question, I kept train and test separate. And now what we're going to do is we're going to define our independent and dependent variables. So Y is your target, X is your train, and X test is test. And so Y is your dependent variable, and X test are your independent variables. And now what we're going to do is we're going to use sklearn to split the sklearn's train test split to split the data set up into training and validation sets. And then we also check the shape. So you can see that there's only 7 columns of data in xtrain, xval, xtest, and ytrain, yval, there's only 1 column of data. So now what we're doing is we're getting up to TensorFlow. And so we want to import TensorFlow and its associated modules. So we're going to import Keras and import layers, and we're going to print the version of TensorFlow. And in this instance, we're using version 2.12. And now what we're going to do is we're going to set the weights. And I did the weights 2 ways. The first thing that I did was I used sklearn to calculate the weights. So this is the code to calculate the weights in sklearn. And then the second method that I used another method that I got from this website, which does basically the same thing. It says weight for not fraud equals 1 over not fraud times not fraud plus yes fraud over 2. And then weight for fraud equals 1 over yes fraud times not fraud plus yes fraud over 2. And then so that gave you really close values that you got from sklearn. So that's just 2 ways that you can calculate your class weights. And you need to calculate your class weights because this is a class imbalance problem. And now we're going to define the model. And so I was having problems getting the neural network to work, so I decided I'd try out passive-aggressive classifier and see what happened. And just with passive-aggressive classifier on the xtrain, ytrain, I got 49%. So that was just telling me I was in the right direction. But I created an artificial neural network using Keras. It was a sequential network. And basically, so I named it card fraud. I had an input and the shape was xtrain.shape1. Name is input. Added a dense layer of 10 neurons. Activation curriculum. Name is layer 1. Added another layer of dense 10. Activation is switch. Name is layer 2. and then I added another layer. Dense is 1, activation is sigmoid, name is output. And you could add some dropout layers in there if you wanted to, because previously what I had done is I had added dropout layers. Technically speaking, you can add dropout layers to try to improve the accuracy, but I removed the dropout layers just to see if I could improve the accuracy by removing the dropout layers. So it scored just slightly better with the dropout layers than it did without the dropout layers, and I'll show you. So we've got a summary of the neural network. And then what we've done is we compiled it. We used our optimizer as Atom, our loss as binary cross entropy, and our metrics as accuracy. We set up callbacks, and I set it for epochs as 200, but it didn't really make any difference. It didn't make any difference with the callbacks. But history, this is our training model. History equals model.fit, xtrain, ytrain. Epochs equals epochs. Validation data equals xval, yval. Verbose equals 1. Class weight equals class weight. And callbacks equals my callbacks. So let's just see something. So one is class weight and one is class weights. But the class weights, the values were very similar. And what I had problems with was the early stalking. For some reason, the accuracy wasn't working. And I couldn't understand why the accuracy wasn't working. And then I plotted a graph using Matplotlib so you could see the loss and the val loss, and you can see the accuracy was 0. So, and then you've got your evaluated xval, yval, and it had a loss of 0.691 and accuracy of 0. But I made predictions on ypred, model.predict xval, ypred equals ypred greater than 0.5, s-type, int 32, ypred equals ypred flattened, ypred. So you can see the ones and the zeros. And this is what it looks like. It doesn't look like what it should look like at all. And I checked the accuracy, and the accuracy was 51.2%. And then we put it on a confusion matrix. And so you can see that there were a lot of ones that should have been zeros and a few zeros that should have been 1. And then we predict on the test set. And then I made a disk plot of that, and you can see that it's not what it should be. But I went ahead and prepared my submission anyway. Submission fraud equals predictions. Submission.toCSV equals submission.csv, index equals false. Submission equals pd.readCSV, submission.csv, and then submission. So this was my submission. And I submitted my work to Kaggle, and I only got like a 40%. And that was without the dropouts. And then so you can go through and do the dropouts, and then it will improve it a little bit more, 40.497%. And that was it, really. I did my best. The highest score was 50, so it didn't do a very good job of the class imbalance. There's other ways that you can do class imbalance as well. You can do smoked. That's where you oversample and then you can also do undersampling, but I prefer to use balanced weights as well. So you can see that we didn't get a very high score when we were using credit card fraud, but just keep trying. When I finish this code review, I think I'm going to go ahead and put the dropout back in and create a heat map and see if any of the columns are highly correlated, and if the columns are highly correlated, then what I'll do is I'll delete one of the columns that's highly correlated. I'll try that out. But I just wanted to show you the code, even though it didn't work out that well, but I was only 10 points lower than the highest score, so it didn't matter what you did, it still wasn't going to work very well. So I'm going to go ahead and conclude this presentation. Thank you so much for watching my video and looking at the code. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more videos for you in the future.